In this lecture, we are going to discuss about spherical plate capacitors. Before studying spherical plate capacitor, you need to understand what is the word capacitor mean. What is capacitor? Dear student, capacitor is a device which is used to store electrical energy and then it's transferred or supplied that energy at the particular instant. So we can write, uh, we can basically write a definition of capacitor, that capacitor is a device or it is an electronic component which store electrical energy and release or supply the stored electrical energy at once. At once. Children, please keep in mind that the electrical energy stored in capacitor is in a form of charges or electrical charges. So initially in capacitor, electrical charges are stored, and whenever the electrical charges are stored, then at a particular instant, this capacitor battery basically transfer or supply the stored electrical charges or the stored energy. And due to this, basically devices or electronic component which cannot run at lower current or lower voltage, they basically start to run. The ability of a capacitor to store a charge is known as a capacitance of capacitor. Capacitance of a capacitor is the ability of a capacitor to store charges, is known as capacitance of capacitor. The capacitor having ability to store more charge is known as an efficient capacitor. So basically, dear student, capacitance of capacitor is calculated from the formula of capacitor, and as you know that the formula of capacitor is Q is equal to C into V, whereas C is a capacitance of capacitor, V is a potential difference, and Q is basically a charge stored by a capacitor. So the capacitance of capacitor becomes C is equal to Q divided by V. So capacitance of capacitor is a ratio of a charge stored to a potential difference. Now students, since you know that capacitance of capacitor is C is equal to Q by V, so we can basically draw a unit from the formula of capacitance of capacitor. The unit of charge is basically coulomb, and whereas unit of potential difference is volt. So the unit of capacitance of capacitor is equal to coulomb per volt. This is SI unit, and 1 coulomb per 1 volt is known as 1 farad. So dear student, farad is also a unit of capacitance of capacitor. Dear student, on the basis of shapes of capacitor or physical appearance of a capacitor, capacitors are usually divided into three main types. First type of capacitor is known as spherical shaped capacitor, spherical plates capacitor. Second type of capacitor is known as parallel plate capacitor, parallel plates capacitor. And third type of capacitor which is commonly used is a cylindrical plate capacitor. So on the basis of shapes of plates, plates of capacitors, the name of capacitor is basically given. So we should now keep in mind that you know that the capacitance of capacitor is equal to C is equal to Q divided by V. Keep in mind that capacitance of capacitor does not depend on the amount on the charges or potential difference, but capacitance of a capacitor is a quality, though equation is this one, but capacitance of capacitor basically depend on the diameter of the plates and as well as the geometry and as well the geometry of plates. So basically it's depend on the nature of material which is used, and secondly it's depend on the geometry of the material or the shape of the material used in a capacitor. Basically, dear student, in capacitor there are two types of plates. The capacitor consists of two plates, and these plates are conducting materials. These are conductors, and the charges are stored inside the charges are basically stored inside these conductors are on the surface of the conductors. So now consider that we have a spherical surface, or we have a spherical conductor. Suppose this is a spherical conductor, and this spherical conductor, let us give name to spherical conductor as S, and charges are basically stored in capacitors or plus Q charges at the surface of the spherical cylinder. This is origin, and distance from origin to the surface of sphere is basically R, or it is the radius of the sphere. So now let us calculate the capacitance of this spherical surface. Since you know that capacitance is equal to C is equal to charge stored by potential difference. And as you know that potential difference, V according to Coulomb law, potential difference is equal to 1 over 4 pi epsilon naught into Q divided by R. Suppose this is equation number 1. If we incorporate this equation 1 in equation of capacitance, we can get that capacitance C is equal to Q divided by 1 over 4 pi epsilon naught into Q divided by R. So this Q will be basically cancelled with this Q, and we can get basically capacitance as C is equal to 4 pi epsilon naught into R. So student, please keep in mind that capacitance of a spherical surfaces is equal to 1 over 4 pi sorry, it is equal to 4 pi epsilon naught r, whereas epsilon naught is permittivity of a free space. Permittivity of free space. So now, and r represent a radius of a sphere. So now, students, let us discuss about the spherical plate capacitor. So before this discussion, we discussed that what is capacitor, how the charges are stored in capacitor, what is the unit of capacitance of capacitor, and how what is the value or what is the formula for a capacitance of a capacitor when there is a spherical surface. So after this, we will discuss about the spherical capacitor, that what is the construction, how the spherical capacitor is constructed, and how we can basically calculate the capacitance of a spherical capacitor. Now, a spherical plate capacitor consists of two spherical metals, and these spherical metals are conductors, are concentric, and they have a same center. So we can define a spherical plate capacitor as it is a capacitor or a device consists of two concentric spheres having a same center, and these spheres are conducting spheres. We can write the definition of spherical plate capacitor, that it is electronic component or device consists of two conducting spheres having same center, or we can define them as spherical capacitors. Our capacitor consists of concentric two spheres. Usually the spherical capacitors basically they consist of an internal conductor, and that internal conductor is covered by a hollow conducting sphere around it. Then please keep in mind that it is not necessary that internal sphere of the spherical plate capacitor is as a whole is a bulk conductor. It could be a sphere, but important point to notice here is that the charges stored on the internal conductor are just because of the nature of conductor, it will be on the surface of the conductor, whereas the second conductor will basically cover the internal conductor, and there will be a hollow region between the internal conductor and as well as the conductor which is basically covering the internal conductor. And the space between the internal conductor and the external conductor, spherical conductor, is known as dielectric. And in usually most commonly the region between the internal conductor spherical conductor and external spherical conductor is empty, and that is the reason, that's why permittivity epsilon naught is used in capacitance of capacitor. However, if there is another medium present between the internal capacitor and external capacitor, then relative permittivity or relative permittivity will be used. So students, we can basically diagrammatically we can represent a spherical plate capacitor as spherical plate capacitor consists of an internal conductor. Suppose this is a schematic representation of internal spherical conductor, and after the internal spherical conductor there is a gap, and after this gap there is an external spherical conductor. Let me write a suitable drawing for it. Suppose that the first one, this suppose say that it is S1 conductor, a spherical conductor, and after that there is an external conductor, and let's say the name, give the name to the external conductor as S2 conductor. And please keep in mind that this internal conductor S1 could be S1 could be a hollow sphere, or it could be a bulk metal sphere. However, the conductor S2 in spherical capacitor is basically it is a hollow conductor. So suppose that the distance from these both the conductors S1 and S2 have a same origin, and that is the reason they have concentric origin O. That is the reason they are basically they are said that they act as a spherical capacitor, or they are present in a spherical capacitor because their center of the spherical one S1 and spherical S2 is basically same, or they are concentric. Suppose that the uh, distance from the origin to the spherical one surface is a. It is basically a radius of a cylinder of the sphere S1, and similarly the radius of sphere S2 will be more, and it is because it is present outside of spherical one, around the spherical one, so it will be, suppose it is B. So in spherical plate capacitors, there are two possible cases. In one case, the external sphere with S2 is basically, or the external sphere is earthed. Whereas in second case, in spherical capacitor, internal sphere is earthed. Any spherical surface which is earth in a capacitor have no charge, whereas the surface which is unearthed is basically have a charge, or it is charged when a potential is applied across the plate of the spherical capacitor. So there are two possible cases possible in spherical plate capacitor. First case is that external plate may be earthened, and when external plate is earthened, the interior will be charged. The internal plate S1 will be charged. And whenever in second case, if the internal plate is earthened, then the S2, the external plate is charged. So now let us consider both these cases and calculate the capacitance of a spherical capacitors by considering these two cases. First, consider that external sphere is earthed, then what will be the capacitance of capacitor when external sphere of a capacitor is earthed? So now let us draw a diagram for earth. That this is a diagram for earth where the external sphere is basically earthened. So now the external sphere is earth, so then this means that this capacitor will store the S1 uh, sphere of this capacitor will store a charge. Suppose that this sphere store plus Q charge. This charge will be uniformly distributed in this S1 sphere. So whenever the internal sphere, the surface of the internal sphere, the charge are stored at the surface of internal sphere, the stored charge will basically induce opposite charges on the internal surface of external sphere. This sphere, a conducting sphere, will uh, basically induce a charge on inside of it, and these charges will be opposite charges. So negative q charges of equal but opposite magnitude will be stored on external S2 sphere like this. And whenever the positive charge or negative charge are basically induced in external plate at the internal side of the surface of the external plate, these negative charge will result into production of opposite charge on the outer surface of the S2 plate. So basically we will write that they generate plus Q charge, and these opposite charges will be generated on the opposite side of the surface of the plate like this. Now, this an important question to note here is that the negative charges are the negative charges at the surface of the plate S2 have basically generated an opposite positive charge on the opposite surface or on the other side of this plate. Internally, its surface have negative charge, and these negative charge basically will induce or produce positive charge at exterior of the surface S2 of the spherical plate. Now, as you know that this plate, external part of the surface of this plate is grounded. It is connected with grounded. So this means that the effect of positive charge on S2 surface exterior will basically cancel, and net charge or exterior of this S2 will be 0. Now please keep in mind that positive charge do not go to a ground. However, from ground the electron will go onto the exterior surface, or negative charge will go onto the exterior surface of S2, and they will basically neutralizes these positive charge. So there will be, so this means that due to ground there will be no charge on the exterior of S2 sphere. So this diagram will become, let me redraw the same diagram again. It will become, please keep in mind that it is quite difficult to redraw it. So suppose that this is plate S1, and suppose this is another plate, which spherical plate, which is present outside of this plate S1, and this plate is S2. This is S2. Now, as you know that we have mentioned that this is origin of the sphere, and the distance between the surface of the sphere and origin is a for S1, and whereas distance from origin to the surface of plate S2 or sphere S2 is b. Now, dear student, the charge on the plates will become uh, is positive charge on the surface of this plate plus Q plus Q plus Q plus Q plus Q, whereas the negative charges are produced or induced on the up on the exterior plate, and these charges will be negative Q, 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 and so on. So now the exterior of this plate is basically earthen, so it is like earthen like this. So on the exterior surface of the S2 there will be no charge, because the negative charges basically they neutralizes the positive charges which were basically induced by these negative charges which are present on the internal surface of S2 sphere. In such case, how we can basically calculate a capacitance of capacitor, where the electric field of lines which are basically produced from positive charge and they go toward the exterior sphere S2, then how we can, and electric field of lines are non-uniform, then how we can calculate a capacitance of a capacitor where the charges are stored at interior sphere or sphere which is present inside. Children, please keep in mind that the capacitance will be basically present at there will be a potential difference between a capacitor between a conducting sphere S2 and as well as a conducting sphere S1. So as you know that the capacitance of capacitance Q is equal to, as you know that for a capacitor Q is equal to C into V, and whereas capacitance C is equal to charge divided by potential difference. Now we need this, suppose that this is equation number 1. In order to calculate the capacitance of capacitor, we need to calculate the potential difference V. We need to calculate this whenever we calculate a potential difference between A and sphere A and sphere S and S2, then we can easily calculate the capacitance of capacitor. And the potential difference will be basically, it will be V will be equal to potential at A minus potential at B. So now let us calculate potential VA. What is a potential at capacitor at sphere S1? We can easily calculate this, and it will be equal to, a potential created by this sphere minus potential at this surface S2 because of this sphere. So the potential created by VA will be equal to, we can write the equation as K, which is a Coulomb's constant, KQ divided by A is the radius of sphere 1, plus K into potential, which is basically created minus Q, and divided by B, by this is minus KQ divided by B is basically, it is a potential which is created by due to a VA on the by the VA on the VB or at the surface S2. So minus, it will be K into Q divided by B plus K minus Q divided by B. So now, dear student, please keep in mind that VA potential. Sorry, let me clear it. The total potential is equal to a potential caused by a sphere S1. So it is VA potential. So we can write a VA potential as the total VA potential. It is caused by sphere 1. It will be KQ, which is basically due to the which is basically due to a radius s of the sphere. It will be kq divided by a. So this sphere has a charge, and this charge I have basically they induce a potential on the surface. So it will be the potential due to this sphere will be kq divided by a plus k minus q, which is basically potential created due to this sphere on the surface, minus q divided by b. And similarly on the surface there are negative charges, so the potential will be due to the charge from this due to a positive charge kq divided by b, the radius of the sphere s2, minus the negative charge which are present on the sphere. It will be plus kq minus q divided by b. So now we can calculate potential from this equation, that suppose that v is equal to, we can say that total potential V is equal to, let me take the K and Q as constant. So we will basically get 1 over A minus 1 over B minus 1 over B minus 1 over B. So this equation become V is equal to KQ into minus 1 over A minus 1 over B into minus 1 over B plus 1 over B. So this minus 1 over B will cancel, plus 1 over B will cancel with minus 1 over B, and we can basically get a potential as V is equal to KQ into 1 over A minus 1 over B. The potential difference become, suppose this is equation number 3 and suppose this is equation number 2. So equation number 3 we will take LCM, and equation number 3 will become V is equal to KQ A B into A minus B. So this is basically potential difference whenever the internal sphere of a spherical capacitor is charged. So now the student incorporate equation number 3 in equation number 1 of a capacitance. So we can get basically capacitance is equal to C is equal to Q divided by V. And as we know that V is equal to K Q B minus A divided by AB. So this Q will be cancelled with Q. So we can basically get C is equal to A B divided by K into B minus A. And now the student, as you know that according to the K is basically Coulomb force, which is equal to 1 over 4 pi epsilon naught. So we can suppose that this is equation number 4, so we can basically incorporate 5 in equation number 4, and we can get a capacitance as C is equal to 1 over 4 pi epsilon naught into AB divided by B minus A. Sorry, let me rewrite this equation. I've written this equation wrong. We can, whenever we incorporate equation number 5 in equation number 4, we can get capacitance C is equal to AB divided by 1 over 4 pi epsilon naught into B minus A. So this 4 pi epsilon naught will basically go upward, and we can get a capacitance as C is equal to C is equal to 4 pi epsilon naught A B divided by B minus A. So basically, dear student, this will be a value of capacitance whenever the external sphere of a spherical capacitor is grounded. Now, dear student, please keep in mind that there is another interesting point. If there is a dielectric medium or any other medium than a free space between the two spherical plates, then we need to incorporate epsilon naught or in this equation. So in such case, the capacitance of a capacitor will be 4 pi epsilon naught into epsilon naught r, which is permittivity, relative permittivity, and a b divided by b minus a. So equation for the capacitance of capacitor will be changed with a dielectric medium if it is present between the two spherical plates. Now is been considered a case two for spherical plate capacitor where the internal metallic or conducting sphere metallic sphere is grounded. Then in this case, what will be a capacitance of a capacitor where the spherical capacitor where the external plate of a spherical capacitor is charged? So suppose that this is internal spherical plate, and we again give it name as S1, and this is external. Let me write it with other color. This is external sphere S2. Let me draw it very clearly. So this is external sphere S2. The radius of sphere S1 is A, whereas the radius of sphere S2 is B. Now, suppose that this S1 sphere is grounded internally like this, it is grounded. So there will be no charge on S1 sphere. S1 sphere, when it is grounded, charge will be 0. Whereas S2 sphere will be charged positively, or it is charged by any charge. So we can basically suppose that this plus Q is charged, the S2 sphere is charged with the positive charge plus Q, like this. Now student, please note that this plus Q charge can basically induce a charge inside the sphere S2, and these charge could be indifferent in magnitude, they could be Q2. So these Q charge plus Q charge could basically induce Q2 charge inside. So this means that net charge Q, suppose that total charge is Q, and it is basically divided into Q1 and Q2 charges when are split into magnitude of charges due to induction from the exterior of the S2 sphere. So the Q1, the Q charge will basically change into Q1 because of induction of some amount of induction of positive charge inside, and whereas internally there will be a plus charge, but it will be plus Q2 plus Q2 plus Q2 due to induction plus Q2 plus Q2 and plus Q2. Now, due to this positive charge on the interior surface, induced positive charge on the interior surface of S2 sphere, there will be a production of opposite charges on a surface of S1 surface, and these charges will be negative charges of same magnitude as plus Q charge, but they will be negative charge. So these negative charges will be generated because of the plus Q charges, which are basically present at interior surface of the sphere S2. So student, in case 2, the internal sphere S1 is grounded, whereas the external sphere of spherical capacitor S2 is charged. So this external sphere S2 is charged by charge Q, and whenever this external sphere is charged by charge Q, this sphere is conductor, so there will be induced Q2 charges. So this means that the charge are which were basically used to stored on the surface of S2 charge, they are basically divided into Q1 plus Q2 charge, because some of the Q charge they cause the induction inside the surface of S2 sphere. So they, since when the charges induced, positive charge are induced at interior of the S2 sphere, this positive charge will cause the induction or production of a negative charge on the grounded sphere S1. So now we can easily see that there are become two types of devices. One type of device is a spherical capacitor, which is basically a potential difference between this sphere S1 and as well as the internal part of the sphere S2, whereas the other will be an isolated conducting sphere, which has a spherical, which have a plus Q1 charge, but they are present at exterior of the sphere S2. So we can write that the second device is a second device is isolated, isolated conducting sphere. So the net capacitance in this kind of device will be, total capacitance will be because of a capacitance of a spherical capacitor plus the capacitance of a sphere. So we can basically get a net capacitance as we have calculated the capacitance of a spherical capacitor in our case 1. We can write basically the value of the capacitance of capacitor spherical capacitor as 4 pi epsilon naught BA into divided by B minus A. And whereas we have previously calculated that capacitance for a spherical normal conducting surface is 4 pi epsilon naught R, whereas we are using the surface S2, so the R for S2, radius for S2 is basically B. So this will be a total capacitance of capacitance for in a case whenever ground is basically the S1 or internal sphere is grounded in a spherical capacitor. So let make it simplify this equation. So we can get C capacitance is equal to, take 4 pi epsilon naught as a constant. So we will basically get BA divided by B minus A plus B, and by simplifying this equation we get capacitance of capacitor spherical capacitors with internal grounded setup as 4 pi epsilon naught into B square divided by B minus A. So in second case This will be the capacitance of a spherical plate capacitor whenever the internal sphere of spherical plate capacitor is rounded. So dear student, this is all about the spherical plate capacitor. Spherical plate capacitor consists of two spherical plates. One spherical plate is present inside the external spherical plate. Both the spherical plates are concentric. They have a same origin. So this is all about spherical plate capacitor. So thank you for watching this.